Okay, thank you very much for the welcome. I'm quite excited, and the OpenMBE leadership and community in general, that we made it to the Models Conference. There was quite some work and also support from the Models people, and including you, Daniel, and Jürgen Dingel also, who I want to mention, who helped us to get the OpenMBE workshop going yesterday, which I think went very well. So let me start with a quick overview of who we are, and then we'll talk about the background, what our motivation is and why we're doing the things that we're doing. So the OpenMBE OpenMBE is a community for open source modeling software and models. It was created or established out of the need of several organizations to create a model-based engineering environment to deal with the challenges of building complex systems and help with the transformation of system engineering into a model-based paradigm. It started with some core software that the JPL released a few years back and has been growing since then. People start to contribute, adopt it, and we have quite a number of participants and adopters now in that community. We're counting more than 400 members, and it's very practitioner driven. There's a lot of industry. There's also some academia, and I think the goal to participate in the models is to bring three communities together: the practitioners and industry on one side that have the requirements and the needs, academia, the rich academic environment, and the community of the models, where there's a lot of brain power that could help us to find solutions, and the vendors who can commercialize it, so we can in the end buy those products. So that is somehow the goal or the vision that we have with this participation in the models. But where did it all start? So Chris, you want to talk about that first few slides?
Sure. So yeah, and Robert and I worked together on this in various ways, going back to INCOSE Symposium in Singapore, which I don't even remember the year, but
2009.
There we go, 2009. You're about my truck. So systems engineers are the key focus of this environment, and focusing on what they do. And today at JPL and other places, systems are complex, and there's ever more collaboration associated with building them, and systems engineers in particular are tied up in this because of its interdisciplinary nature. So systems engineers have the ability to do their own system level designs thanks to MBSE, but they also have that compels them even more to collaborate with the other disciplines in engineering to build these modern complex technical systems. So that requires leadership, architecture design, and the management of complexity. So it's a lot of things to bring together. And these days teams are quite large. So this is a picture. Is this still Cassini, Robert, or did we?
That's still Cassini. Yeah.
Okay, so this is the picture of Cassini. We're going to update this slide shortly with a picture of the Mars 2020 team, which is even bigger, if you can believe it. But that's a lot of people to work together and build what in this case was the exploration vehicle for Saturn, and what most recently is the most sophisticated rover yet that will shortly be on the surface of Mars. So all these people have to talk and communicate and bring all their pieces together into a system that works. So
can you tell the story about the memos in Cassini?
Oh yes, right. So Cassini has sorry, Robert will have to cue me a little bit. It's 6 o'clock at LA. So yeah, so in the days of Cassini, we didn't have the internet. It was built in the 90s. Well, the internet was pretty new, and doing engineering with software was pretty new. So on Cassini, they had this conventional document system where when there was a new change to decided about the system, the technical authority would issue a memo via typewriter and interoffice mail. And there was an army of people with typewriters and everything that would take these memos, and they would read through all the documentation and impact the changes and publish new volumes and distribute them to everybody. So the information creation cost was expensive. And there was this team of people whose job it was to make sure that the information was correct. And since then, obviously that's changed. It's now quite cheap to circulate an Excel spreadsheet or a Word document or a PowerPoint deck with lots of rich technical information, but we no longer have this group of people that impacts it and ensures that everybody gets the same copy in the same way. It's much harder to do because of the cost of information. So today a project starts simple. There's a few documents and most notably a few people, and people iterate on their models, and the material starts to grow, and more people are added to the team, and more documents are created, and more people are added, and more models are created, and the information itself starts to become complicated. And before you know it, it's an overwhelming number of people and documents. And now if you're this little meeple in the middle and you just joined the team, it can be quite difficult to figure out what's going on and where everything is and what you need to know, and if you have the right email from so and such and such. So
Yeah,
this was the situation that we faced.
exactly. I mean, and the main product of system engineers are still documents. There's engineering work involved, but the documents are the primary artifact that is delivered. Especially
in the United States government. Most of my job is data entry, right? These are, so we for modern engineers coming out of school too, they don't want to spend their time docu-jockeying and PowerPoint ranging and accelerating. They want to do real engineering work. They want to have a meaningful impact on the system, and they've been taught all of these modern skills in CAD tools and Python and MBSE and SysML and stuff like that. They want to use those skills. So that's another aspect to consider in this as well. So these are kind of some quasi classifications of real engineering versus overhead. And I think Robert and I would argue that the organization's best use of their talent isn't doing this stuff, right? Repetitive data entry, version confusion, constant searching. These aren't the tasks that we want to be paying our engineering talent to spend their time on. I mean, some of it is unavoidable, but there's a quotient that develops here that starts to make it unreasonable. So a better way is to take this mess and reorganize it into something that's congruent around a sane process for managing the information, which allows software to maintain all of this interactivity, and in particular, the relationships between these things, so that it's a body of information that still produces the documents and the products that people expect, but instead is searchable and navigable, and you can understand that impact the way the memos from Cassini work.
Yeah, we want to shift away from an email culture, which is still kind of dominant. People send around the Excel sheets, right? We want to shift to an authoritative source, single source, unified resource, right? That the information is connected within and between those documents with the engineering work, right? So you have the typical situation where you perform some engineering task, you have your engineering model, for example, and then you copy paste it into some document, and then you lose the connection immediately. And as it moves on, this disconnect becomes bigger and bigger because you start to copy paste stuff. So we want to bridge this gap between the engineering work and all the accompanying documentation which is created. Chris?
So this illustration is intended to convey the concept around the user experience that we want to convey with OpenMBE. So this update once, use everywhere notion, where you know, this individual who's maybe working on their actual like their physical model of the spacecraft, and this individual is working on maybe their SysML model, and possibly most importantly, this individual who's working on a document description of some aspect of the system that they have to deliver as part of a gate product, are all referencing the same information. So there's no, you know, the other two people in the equation may not even realize that when an update comes their way, the engineer that made that update was in a different tool when they did it. So the OpenMBE stack, if you will, is made up of some key pieces. And at this point too, we introduced not only the idea of a software platform that can do these things, but the idea that as a companion to that, we should be practicing open source practices in the model-based engineering world. So we have the model management system, which is the core repository that manages the federation of references and so forth. We have the view editor, a model and platform for model analysis, which is the document-based interface with this companion based on Jenkins that allows you to run analyses and executions behind your document to do some of the updates. And the model development kits, which is really the integration strategy for how we integrate various commercial and open source engineering tools into this environment. So we have several MDKs you can see on the website. We have a DoorsNG MDK, a Magic Draw MDK, MATLAB,
Mathematica, Python.
Yeah. So, and then we have a component of documentation and training, and then the Robert's 30-meter telescope model that he open sourced, and the cookbooks, which really bring into the idea that with an open source community, the future is not just having this platform where we can share this information, but that engineers can start with vetted, well thought out models and libraries, and benefit from open source practices the way software developers benefit. So we connect up this platform in this representative way to see that the model management system can act as the gateway for the authoritative source. You have MDKs where different engineering modeling is taking place, and view editor for consumption of those models in the traditional styles that they're used to. And then as an example, you can load in the 30-meter telescope, and you can load in the cookbooks and have a full functioning environment for doing engineering modeling. So Robert will do a demo now.
Yeah. So the little demo is a simple example where you have the authoritative source of your engineering model. You have one flight system engineer that has to analyze the MEL, as we call it, which is the key product in for spacecraft, and an SME, the subject matter expert, that has to create a document, a report on that MEL. So here's the video, and I'll comment while we go along. So what you see here is what we call the view editor, and the view editor basically is a view and viewpoint oriented projection of the system model, which can come from different sources. As Chris mentioned, MMS has federated cross references, but basically you work on a document, so that the natural environment for many system engineers, but it's hooked up at the back end with the model. So whenever you change something on there, it will actually change the model, but it lowers the barrier of access for many people. Many people will never open a modeling tool and draw some diagrams. They they have their tables, which are the beloved tables, like this one, where we have a list of the equipment with a mass and some properties. And we're starting to change that on that web application. And as soon as we save, it goes back to the model. So that one person changes it on one side, and it goes back to the model. On the other side, we have another integration. In this case, it's MBE that you will see later on. There's a talk about it. But you update the model and in Excel, and it refers to the same data. And Excel is another tool that system engineers like, right? So, and then they would add another component by simply inserting a row. And when they are doing it, the tooling takes care that it conforms to the modeling structure behind. Would do a commit, which again updates the model, and on the other side, the document would be updated, so there is an additional row. So that's a very simple example, but that somehow shows you how it works. You have MMS in the middle, and a number of applications that can access, modify, author, analyze that data that is available. So the OpenMBE, as mentioned before, has started some years back and has grown into a rich community of adapters and contributors across various disciplines. So you see NASA and their projects where it has been used, science and engineering, the 30-meter telescope was mentioned. I worked with a team to produce a completely model-driven engineering documents. Industry has adopted it, most notably Boeing, Ford, and Lockheed. It has been used for developing the SysMLv2 standard with OMG and in COSI. And also, and that is very important, vendors have picked it up and built integrations for it. So we give a short, brief history of where we started. The first big project was Europa Clipper, where OpenMBE core software has been used. And there have been about 100 concurrent users to produce more than 230 documents. But the most important number is there's 445,000 connections between those documents and the model. And what all these connections that used to be implicit, right? You have all these documents and they are somehow connected. You don't know if a number is the same number in one document versus another. But now they are explicit, or at least many of them. Of course, there are some which are still there because that's a process. But the number tells you with what kind of complexity we are dealing with here, right? Chris has a very brief story on one anecdote from that project. So maybe Chris, you can tell that in a few seconds.
Sure. So when I was on Europa Clipper early on, there was an event where it was a fairly minor event. There was a document that needed to be produced for an independent cost evaluation of the project, and it had somehow not gotten done and not gotten started early enough, and so it was a bit of an issue with the project, how to get it started and get it completed as quickly as possible. And it was the kind of thing, it was a kind of a comprehensive description of our understanding of the mission at the time. So it would have taken several people to get together and bring all their spreadsheets and documents together and sort everything out. It probably would have taken a week just to figure out who had to put what where, and then they would have had to stitch it all together and everything. And the modeling team generated it in 4 hours. And not only was it generated in 4 hours and correct, it was mutually consistent with all of the other documents that the project was managing out of OpenMBE at the time. So those benefits were quickly realized in a pinch. And that was the only time the project manager ever smiled at me. So I was walking down the hall. So
at that time, so for Clipper, it was the impact was a reduction of overhead to manage all this data. There's some quotes from flight system engineer. I'll skip over them in the interest of time. The next step it took was with Mars 2020, that is currently on its way to Mars. And there, the impact was on the technical rigor. So 50 concurrent users, 90 documents, 180,000 connections, and with the emphasis of precise engineering documents that is also integrated with the subsystems. So like reference designators, electrical function list, and functional block diagrams. But so another interesting thing is the international standards. So the OMG has been producing modeling specifications for modeling languages and other things for decades with Visio and PowerPoint. Surprisingly, but with SysML 1.5 and SysML v2, we finally have reached the step where we can generate that documentation, right? So the whole SysML v2 and SysML 1 specification is model-based and generated using the OpenMBE core software. And there's quite a number, I think there's more than 60 organizations, meanwhile, tens of contributors and hundreds of consumers. And the interesting thing there is because we know it's model-based, we have a much better idea also what the connections between those elements mean. So there are 6 documents produced at the moment. But would it scale was the question, right? Because you have many systems that do similar things, but would it scale? And Boeing and Lockheed showed us that it does. So Boeing adopted it and had some time ago around 1,000 concurrent users across 50 programs, and Lockheed with 100 users and across 50 projects. So the demonstrated enterprise scalability is a key element in this effort. But would it work also across organizations? And Stevens did a very good case study, and Mark Blackburn will talk about that later today, together with Naver to demonstrate how OpenMBE can be used for acquisition and inter-organizational collaboration with sign-offs and producing CDRLs and DIDs, using View Editor again and MMS. So, Chris, you want to talk about the vision?
Yeah. So today we can see that there are cases where people are using OpenMBE to gain this experience between this information within their organization, the so-called intra-organization. But the vision is that we could take things beyond that and go to this inter-organizational concept. So leveraging on the internet and open source practices, there could be a future where we could connect these deployments of OpenMBE directly between these different organizations. So this is the concept we're trying to employ for Mars sample return, where people will be able to connect between their different deployments and connect this information so that stuff that's being built for different parts of the mission can still be connected and interoperated across greater distances, with this global vision that one day we'll be able to connect across this entire fabric of models and cross references, so that perhaps everybody will be referencing the SysML specification itself and other modeling language specifications in a hosted way, and deploying them across their different environments and using different model libraries, and being able to develop this seamless collaborative fabric of interactivity, even better than what open source software enjoys today.
Right. So this global engineering ecosystem vision is somehow comparable with the web. I worked at CERN in 1990 when the very first web server went online. I was there when the internet was invented. And with OpenMBE, I hope to be in a similar position when the global engineering system was invented. So we also have some recent updates. So we have become very recently a a NumFocus sponsored project together. So NumFocus is the organization that hosts, for example, Project Jupyter, which is also a key element in our MBE strategy together with SysMLB2. And maybe interesting there for the academic community is that you can also apply for funding if you want to develop anything for OpenMBE, and then it will be looked at. And I think that's